All right, so in this video, we are going to do a sample chapter 9 quiz, and it's going to have 9 different questions. So let's begin. Question number 1 gives us f of x equals 2x and g of x equals x squared minus 15, and we need to find g minus f of negative 3. So let's start by just finding g minus f of x. G minus f is pretty simple. We're just subtracting the g function from the f function. That's just x squared minus 15 minus 2x. It's just x squared minus 15 minus 2x. You can write this in order if you want, x squared minus 2x minus 15, although there's no difference in this question. And then we're just subbing in negative 3 for x. So g minus f of negative 3 is just negative 3 squared minus 2 times negative 3 minus 15. And I'll put this in my calculator and just get 0. A second question, we have f of x equals x squared plus 1 and g of x equals 3 minus x squared. And we need to find f of x minus g of x, which again is pretty simple. So that's just going to equal to x squared plus 1 minus 3 minus x squared. So here's the reason I put the brackets. You don't really need the brackets at the start, but this negative is going to distribute into this bracket. So I'm going to get x squared plus 1 minus 3 plus x squared. That's a common mistake that people make. They forget about distributing the negative in. We'll get 2x squared minus 2. Third question, we have f of x equals root of 5x plus 4 and g of x equals to 4x plus 5. We need to find the domain of f plus g of x. So f plus g of x is just the addition of these two functions, 5x plus 4 plus 4x plus 5. This is just a simple linear function, so there's no domain for a linear function, which means we only need to worry about the domain of the square root function. Remember, whatever's inside the square root has to be greater than equal to 0. I'm going to move the 4 to the other side, so it becomes negative 4, and then I'll divide both sides by 5. So x is greater than equal to negative 4 over 5. So basically, our domain is x is an element of all real numbers such that it's greater than equal to negative 4 over 5. Fourth question is f of x equals to root of x plus 3 and g of x equals x squared plus 2x minus 8. And we need to find the domain of f of x minus g of x. This time, again, whether it's plus or minus, it doesn't matter. We just look at the individual functions. This is a quadratic function. It has no restrictions on the domain, so we only have to worry about the square root function and the domain right there. So we know x plus 3 has to be greater than equal to 0, which means x is greater than equal to negative 3. So that my domain is x is an element of all real numbers such that it's greater than equal to negative 3. Fifth question, f of x equals to 1 over 3 to the power of x, and g of x equals x cubed, and we need to find the domain of f times g of x. So f times g of x is just this function times this one, which is just x cubed over 3 to the power of x. Now there's no square roots here, so we do have to worry about the denominator, because the denominator cannot equal to 0. But if we think about an exponential function never ever hits 0, which means that the denominator will never equal to 0, which means that the domain is just all real numbers, because there are no restrictions on this question. Okay, question number 6, we have f of x equals x squared minus 14x plus 49, and g of x equals to 1 over x minus 7. And we need to find where f times g of x as a whole. So let's start by multiplying these two functions. If I multiply these two functions, I'll just get x squared minus 14x plus 49 over x minus 7, which is, if I factor the top, it's just x minus 7 times x minus 7 over x minus 7. So I can cancel these, and when I cancel, it's going to create a whole, and the x value of the whole is going to be 7. The rest of my function is just x minus 7. To find the y value of the whole, I just have to sub in the x value into the simplified equation. So 7 minus 7 is just 0. So I have a whole at 7 and 0. Question number 7 is f of x equals 4x minus 9. G of x equals 3x plus 4. And I need to find f times g of negative 2. So again, this is pretty simple. We want to just start by finding f times g of x. And that's pretty easy. We're just multiplying these two functions together. So I have 4x minus 9 times 3x plus 4. I don't even need to expand this out. I can just do f times g of negative 2 next. So I'll just sub in my x's as negative 2. I'll put this in my calculator. This is negative 17. This is negative 2. So my answer is just 34. All right, question number 8. We have f of x equals 1 over log x, and g of x equals to 1 over 8 plus x, and we need to find the domain of f times g of x. So in order to find the domain of this, I just need to find the individual domains of these two functions and combine them. So let's do g of x first, because it's pretty easy. I know g of x, the denominator cannot equal to 0, which means that x cannot equal to negative 8. Now for a log function, and it doesn't matter whether it's in the numerator or denominator, whatever's inside the log has to be greater than 0. So my domain for this function is just x is greater than 0. So now I want to combine these two over here. If I think about it, negative 8 is not greater than 0. So it doesn't matter. I don't need to even include this because it's already included here. So my domain is just all real numbers such that it's greater than 0. If you include x equals and x equals to x does not equal to negative 8 here, that is technically wrong because you're repeating the same solution. This already includes x does not equal to negative 8. And last question, we have f of x equals cos x and g of x equals x squared minus 5x minus 6. And we need to determine the domain of f of x divided by g of x. So f of x divided by g of x is just cos x over x squared minus 5x minus 6. Remember, cos and sine do not have any restrictions on domain. They're all real numbers, which means I just have to solve for the denominator and make it not equal to 0. So that's, sure, I can do that over here. So x squared minus 5x minus 6 does not equal to 0. I can factor this. So x minus 6. X plus 1 does not equal to 0. So this means x cannot equal to -1 or 6. -1 is from there and 6 is from here. So x is an element of real numbers such that it cannot equal to -1 or 6.